Assalamu alaikum. In previous video lecture, we talk about the nitrogen fixation overview mechanism and the different ways to fix the nitrogen, like biological nitrogen fixation, atmospheric nitrogen fixation, or the industrial nitrogen fixation. So in previous video lecture, we discussed the biological nitrogen fixation in which the bacteria are fix the nitrogen. So today we discuss the atmospheric nitrogen fixation. So atmospheric nitrogen fixation basically are also known as a non-biological uh, nitrogen fixation. It is a non-biological nitrogen fixation. So in which nitrogen can be fixed by the lightning that convert the nitrogen and oxygen into the nitrogen oxide. So what happened? There is a lightning. This lightning, it convert the nitrogen and oxygen into the nitrogen oxide. So nitrogen oxide may react with water to make nitrous acid or nitric acid. So when this nitrogen oxide react with water, it convert into the nitric acid or nitrous acid. So which seeps into the soil and where it makes the nitrate which is of use to plant. Nitrogen is the atmosphere is highly stable and non-reactive due to the triple bond. As in previous lecture I already told you that nitrogen, in the nitrogen molecule, they contain triple bond and it is very highly stable. So what happened? Nitrogen in the atmosphere is highly stable and non-reactive due to their triple bond. So in the lightning when produced and they produce enough energy and heat to break this bond. So that allowing nitrogen atoms to react with the oxygen and to forming the nitrogen oxide. So this compound cannot be used by plant, but as this molecule cools, it reacts with the oxygen to form nitrogen oxide. So this molecule in turn react with water and produce nitric acid or its ion of the like nitrate. So which is usable by plants, and then the plants can be used and then again repeat the cycle. So this is happening into the atmospheric nitrogen fixation. So now we talk about the industrial nitrogen fixation. Industrial nitrogen fixation. In the industrial nitrogen fixation, basically it in which different processes are takes place. Like in industrial process, the possibility that atmospheric nitrogen react with certain chemical was first observed by Desfosses. So Desfosses, he firstly observed that atmospheric nitrogen react with certain chemicals, in which he observed atmospheric nitrogen, it react with certain chemicals. In 1828, he firstly observed in 1828. So he observed that mixture of alkali metal oxide and carbon react at high temperature with nitrogen. So with the use of barium carbonate as starting material, the first commercial process became available in the 1860s that developed by the Margaret and the Sordival. So first commercial process that available in the industrially in 1860s, and it was developed by the Margaret and Sordival. So with the use of barium carbonate as starting material, the first commercial process was became available in the 1860s, and that developed by Margaret and the Sordival. The resulting barium cyanide could be reacted with steam yielding ammonia, and the history with prior to 1900, Tesla experimented with industrial nitrogen fixation by using current of extremely high frequency or the rate of the vibration. So there are some processes that are involved in the industrial nitrogen fixation. The first process are the Frank-Caro process. Frank-Caro process. So basically the Frank-Caro process are in 1898 Frank and Caro developed the process. In 18 this process 1898 Frank and Caro, they developed the process and produced calcium carbide. In a subsequent step, reached it with the nitrogen to calcium cyanamide. So basically, the Frank-Caro process are the also called the cyanamide process, in which the nitrogen fixation reaction is a calcium carbide with nitrogen gas in the reactor vessels at about 1000 Celsius, and the reaction with uh, exothermic and self-sustaining on the and in 1898 Frank and Caro that developed this process, and the second are the Oswald process for the production of nitric acid. Second is the Oswald process. Oswald process, it is also used for the production of nitric acid and was discovered in 1902. So this process is discovered in 1902. So basically the Oswald process are the chemical process used for making nitric acid, and William Oswald developed this process, and he patented this in 1902. So, and Oswald process is a mainstay of the modern chemical industry, and it provides the main raw material for the most common type of the fertilizer production. So, and the next process are the Haber process. Haber process. So Haber process are it is discovered in 1909. In 1909. Haber process basically are the most common ammonia production method is the Haber process. Fertilizer production is now the largest source of the human produced fixed nitrogen in the terrestrial ecosystem. So ammonia is a required as a precursor to fertilizers, explosive and other products. The Haber process requires high pressure 200 atmosphere and high temperature at least 400 Celsius. So this Haber process required 200 atmospheric pressure and 400 Celsius temperature. So these are requirements of the Haber process which are routinely conditioned for industrial catalysis. So this process uses a natural gas as a hydrogen source and air as a nitrogen source. So there's much research has been conducted on the discovery of catalysis, different catalysts for the nitrogen fixation, often with the goal of reducing energy requirement. However, such research has thus far failed to approach the efficiency and ease of the Haber process, and many compounds react with the atmospheric nitrogen to give dinitrogen complexes, and the first dinitrogen complex to be reported. So these are some processes that are involved in the industrial nitrogen fixation, and in this lecture we discuss the industrial nitrogen fixation and the atmospheric nitrogen fixation. So these are about the nitrogen fixation and the ways that are involved to fix the nitrogen fixation. If you like this video, like, subscribe and share it. Thank you.